Continuing on with our differentiating examples, we've got y equals the square root of the sine of 1 plus x squared. Now I said that in kind of a loaded way because I wanted to really point out that the square root function is the outside function, the sine function is the middle function, and the 1 plus x squared is the inside function. What I'd like you to do is go ahead and find the derivative and come back when you're done. I want to make sure that this is followed by everybody, so I'm going to kind of walk through this. The derivative of the square root function is 1 over 2 times the square root. The derivative of the sine function is the cosine, so we have a product, right? And then the derivative of 1 plus x squared is 2x. What was inside the cosine function is 1 plus x squared, not changing. What was inside the square root function was the sine of 1 plus 2x, or 1 plus x squared. As far as simplifying, the 2's will divide out, and we have y prime is equal to, I'm going to put x times the cosine of 1 plus x squared in the numerator, and the denominator is the square root of the sine of 1 plus x squared. Our next example is to differentiate y equals x times the sine of 1 over x. And I'm again going to ask you to do the work and then come back. Here we have a product. U is x and v is the composition, sine of 1 over x. So the derivative of u, or u prime, is 1. V prime is going to be the cosine of 1 over x times negative 1 over x squared, using the chain rule for the 1 over x, and that involved the power rule. The power rule. Multiplying everything together, the x divides out with one of the x's in negative 1 over x squared. The product rule has a plus, but 1 over x squared is a negative factor. So our derivative is y prime equals the sine of 1 over x minus 1 over x times the cosine of 1 over x. Continuing on, we're going to differentiate y equals the sine of t plus the cosine of the square root of t. This one we're going to do together because we don't have okay, this is a composition. Clearly the sine function is the outside function. There's a middle function, t plus the cosine of the square root of t, so we need that derivative. But within that middle function, there's a composition in part of it. There's the cosine of the square root of t, for which square root of t is the inside function. But it's not an f of g of h of x situation. That's not what we have here. So we're going to just be a little bit careful here. Y prime is equal to, the derivative of the sine is the cosine, and what the cosine is holding won't change, so I'll just go ahead and put that down as t plus the cosine of the square root of t. None of that changed. Now, let's just take this inside function out all by itself. T plus the cosine of the square root of t. And we're going to differentiate that. So the derivative of t is, of course, 1. The derivative of the cosine is the negative sine. The cosine was holding square root of t, and so I have negative sine of square root of t. And then the square root of t has a derivative. It's 1 over 2 times the square root of t, right? So that's where that chain rule is coming out. Notice, the square root of t is only a part of the cosine function. And so it's a factor only next to the sine of square root of t. I don't have parentheses here to say that 1 over 2 square root of x. Oh, x, that should be a t, my bad. I don't have parentheses to say that 1 over 2 square root of t is going to be multiplied by 1 as well. That's not happening, right? So when I apply the chain rule here, it's what I already wrote down, y prime equals the cosine of t plus the cosine of the square root of t times the derivative of the inside function. And the derivative of the inside function is 1 minus 1 over 2 root t times the sine of the square root of t. There is nothing that can be done to simplify this. That is the final answer.